Okay, so here we've got an arithmetic sequence defined as the nth term equals 135 add 7n for n starting at 1, so the first term, second term, third term. Calculate the first term in the sequence. So the first term in the sequence is so you want the first term equals 135 add 7 times 1. Okay, so that's going to give us 142. Show that the common difference is 7. Now I guess we could just work out the first 3 terms. So U2 equals 135 add 7 times 2, which is 149, and then U3 equals 135 add 7 times 3, which is 156, and we could just show that 149 minus 142 equals 7, and we should show a second one as well. 156 minus 149 equals 7 for D equals 7. I think that would be enough to give us the mark there. Okay, so Sn is the sum of the first n terms in the sequence. Find an expression for Sn. Give your answer in that format. Okay, so we need, from our formula book, we need the sum of an arithmetic sequence, and that's given by the following formula. Oh, something's happening. No, I don't want it to. Stop. Okay, what's going on? Yeah, we're back. It's working. Minus 1 D. Alright. Okay, so I can put in some of the things I know here. So I've got n over 2, 2 lots of U1, which is 142, add n minus 1 times 7. Let's just try and work with that a little bit. Okay, so let's say n over 2, 284, add 7n minus 7. Okay, so I've got, let's just save that till the end, n over 2, I've got 277, add 7n, and then multiply this out. Hang on, and give it in the following form. Okay, so these are constants. So we've got 277n over 2n, add 7 over 2 n squared. And let's just put it the way around that they ask. So 7 over, no, it's down a bit. 7 over 2 n squared, so that's my A, add 277 over 2n. There we go. Alright. Where have we got to then? Let's go up here. Okay, so that's part C. We've done part A and part B. Right, next up. The first term of a geometric sequence is 20 and the fourth term is 67.5. Show the common ratio. Alright, let's go on to another page here. So I've got, what have I got? I've got V1 equals 20 and I've got V4 equals, I can't remember. equals 67.5. Okay, so what do I need to show? Just show the common ratio. What I would normally do here is just put, I've got my 20, that's my first term, then I've got my second term, third term, fourth term, 67.5. I need to times by r, times by r, times by r. So 20 times r cubed equals 67.5. Which then gives me r cubed equals 67.5 divided by 20. And then finally, to get r, I just need the cube root of 67.5 divided by 20. Okay, so I can do that on here. I'm going to do actually I don't need second, in the math menu you've got a cube root there. So the cube root of 67.5 divided by 20. That's that, 1.5. R equals 1.5. Okay, so we've shown that. What's the next bit? Okay, Tn is the sum of the first n terms of the geometric sequence. Calculate T7, the sum of the first 7 terms. Alright, so that should be okay. So the sum of no, that's not this. It tells us to use t. So Tn is going to be u1 times r to the power of n minus 1. That's that's just the term. I want the sum of a sequence, so it's not going to be that. Get rid of all that. Okay, the sum of a sequence is going to be given by u1 r to the power of n minus 1 divided by r minus 1. So in this case, the first term was 20. Okay, so we had 20 times r, which is 1.5. We're after now the sum of the first 7 terms. So 1.5 to the power of 7 minus 1, all divided by 1.5 minus 1. So put that in here. 20 times 1.5 to the power 7, take away 1, close brackets, divided by, need to put all this in brackets, so 1.5 minus 1. Okay, let's see what that gives us. 643.4375. So using 3 significant figures, 643. Let's just check if that's what it asks us for. Okay, calculate the sum. Okay, so we've rounded to 3 significant figures. Use your GDC to find the smallest value of n for which the geometric sequence is bigger than the arithmetic sequence. Alright, so we're going to go and have a look at these sequences in the tables. So we've got 135 add 7n or x, and then the second one was, how was it? Oh no, hang on, sorry, I want the sum. Alright, so I need to go back to, all the way back, right back to here, sorry, Sn. So, delete that. The sum of the arithmetic sequence is 7 over 2 x squared, add 277 over 2 x. Okay, and then my other sequence I get from here. So I have 20 times 1.5 to the power of x minus 1, close brackets, divided by 1.5 minus 1, close brackets. Okay, so let's just see how my table's set up. Starting at 0 and going up in ones. Yep, let's give that a go. Second table. So I've got my Sn and Tn, and the question asked us, oh sorry, I've gone back too far. Question asked us, what's the smallest value for which Tn is bigger than Sn? So when is my value, this one, bigger than this one here? Let's just go down until we find it. Okay, still smaller. There we go. So when n is 9, this one's bigger, and when n is 10, the other one's bigger. So when I display my solution to this, what I should really show is, I'm going to use table. Okay, and I can have n as my x values. We've got Sn and Tn, and I should show 9 and 10 because that's when the change happens. I've got 15301497.7, and I've got 17352266.6. Okay, therefore when n equals 10.